Alright, E, the number E is very similar to pi. So it has lots of the same characteristics. We know that pi is an irrational number. It is approximately 3.14. Now, what makes it irrational is that it keeps going forever. I used to have a poster up, but it fell down. 3.14, blah, 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 and it keeps going. Okay, the reason it can keep going is because pi is actually the ratio of the circumference of a circle divided by the diameter. So it doesn't go into it evenly. So somebody can always figure out what is the next digit of pi. It's irrational, it keeps going into it. E is the same way. E, I can give you, because I've got it in my book for today, I can give you a few more decimals on it. It is approximately 2.7182818284.6, and then that even keeps going. Okay, there is an E button on your calculator. It's down on the left-hand side, across or right next door to the 4. See it in blue there? So if you needed to do E, you would hit second and then that button. But for today's stuff, we're not going to even have to evaluate anything. We're just going to leave the E's in our answers and work with them. Because once you take that E out and put approximately 2.7 in for it, you've rounded, right? So we're going to leave, like you remember in geometry, a lot of times you left your answer in terms of pi, like 7 pi or 12 pi. Same thing with E. You can leave your answer a lot of times in terms of E. So that's what we're going to be looking at mostly today. All right. Here we've got, the smart board's not been smart today. E to the 3rd times E to the 6th. Alright, directions on this say to simplify. So we've covered exponent rules a lot before. That's Kylie's got it down exactly right. When the base is the same, and it is here, E and E, you take that base, and when it's multiplying, your powers get added. So that would just be E to the 9th.
That's it?
Mm-hmm. Now, come on, stupid board. You could actually go and hit E to the 9th in your calculator, but don't. I mean, you can stop there and leave your answer as E to the 9th. What would it be close to, Colin?
That's 8,103.
Cool. Alrighty, if we had 16e to the 5th divided by 4e to the 4th. Okay, we're just simplifying again. What would we do with the 16 and the 4? Divide. It's a division problem. You got coefficients, so you divide. 16 divided by 4 is 4. Then we got a base of e. What do you do with those powers when it's division? Subtract. So e to the 1st is the same as just e. So that's it. Not a whole lot. Alright, this one I've got here says 3e to the, get off there, stupid, to the negative 4x all to the 2nd. Alright, so that negative 4x is just on the e, right? But that squared outside is outside the parentheses, so it goes to everything. So we're going to take that squared. What do we do to the 3 with it? You square it. So that would be 9. Good. Now when we go to the e, this is where what Kylie remembered, it's already got a negative 4x. So we're doing a power to another power. What are you doing? It's a power to a power. Multiply, so that'd be e, and then that would make negative 8x, right?
So you just leave the e and the x, you don't do anything. Like you write it down.
Now we've got a negative power. When we did powers before, we couldn't stop when we had a negative power. What happened when we had a negative power? What did we have to do? Put it on bottom and make it positive. The 9 is not affected by that negative power, is it? So 9 will stay on top. E to the 8x on bottom. Put it on bottom and make it positive. Now, the way this connects with the stuff that we did yesterday, the graph of E, the graph of the number E, is an exponential. Remember we did exponential growth and decay yesterday? So we're going to look at a couple of graphs on them. What you need to know is if we have y equals a times e to the rx, how we decide if we're exponential growth or decay. I'm just copying this down as we go here. It's a growth if both your a and your r are positives. Greater than 0 means it's positive, right? You're a decay when your a is still positive but your r is negative. So if I gave you y equals 3e to the x, and I asked you if that's growth or decay. Okay, first off, what's your a? 3. So that's greater than 0, so that's okay. What's your r? 1. So where does that fall over here? Is 1 greater than 0 or less than 0? It's greater, so this one would be a growth. So we know from yesterday that it would look something similar to that, right? Go ahead and grab your calculator and see if we can graph that. Hit y equals, type 3, second, down next to the 4 where it says ln, and then fill in that power there of x, and hit graph. Okay, it's a little bit sharper than what I drew.
Oh, it said you guys were low. Yeah, they were low.
I got it on the out, so 3, just type in the 3. And then E is on second element. X. Anybody need help? Now if you go look at your table, this is why, y'all know I don't like graphing on the calculator a whole lot. I prefer to do it on my own. But if you look on your table, you'll see why I do that on the calculator. E is an irrational number. It keeps going forever. So look at all those decimals you got in there. Right? That would be a pain to plug all those in individually. Look it up. Alright, let's see. What about f of x equals e to the negative 0.5 x? Is that a growth or a decay? Okay. Everybody agree on that? Okay. Our r is negative half. Negative is smaller than 0, right? So it's a decay. You could graph it and check it and make sure if you needed to. Alright, yesterday we looked at a banker's formula, the compounded interest. We got another one of those today. It's the continuously compounded interest. And that continuously means it's different than the formula that we looked at yesterday. So you'll know to use this one that I'm trying to write here when it specifically says continuously. If it doesn't say continuously anywhere in the problem, you'll use the one we did yesterday. And I don't know how to spell continuously. It took me like 10 minutes to write that. Alright, its formula is A, your final amount, is equal to your principal times the number E to the RT power. And all that AP, R, and T is the same stuff as yesterday. A is the final amount in the account. P is the principal. It's what you invest initially, what you deposit, what you put up. R is your interest rate as a decimal. And T is your time in years. Remember yesterday it had an N in there. So it told you it was compounded quarterly, and we used a 4 for the N. Remember that? This one means it's compounded continuously. So that's why the formula is a little bit different. So they don't wait till 4 times a year to compute your interest. They're computing your interest all the time when you use this formula. Okay, so...
Wait, what's underneath compound AM? Is that what that's about?
Yeah, amount. Yeah.
Oh, amount.
I'm sorry. Alright, so here's the problem we're going to use on that. It says you and your friend each have accounts that earn annual interest compounded continuously. So, see, it said the word continuously, so you would know which formula to use. The balance A in dollars of your account after T years can be modeled by A equals 4,500 E to the 0.04 T. Alright, so that time they gave you everything that we already had there. The question that I want us to figure out here, we're going to do another one in just a second. After 10 years, in 10 years, how much money will we have? So where would I plug a 10 in? The time, right? 10 years would be the T in time. So I'm going to type on my calculator 4,500 times the number E to the 0.04 times 10 power. Come on, stupid. What'd you get? That was part of the problem I read to you. I said after 10 years.
6,715.
So Brooklyn said $6,713.21.
I got something.
I got what Brooklyn said.
Oh, I put negative instead of 1.
Oops.
Yeah, I did that at first too.
I mean, I don't know how you can't read that with all the boxes up there and my messy writing. Alright, let's do another one with that formula and make sure we all right there? Alright, this one it says you deposit $4,250 into an account. So you deposit, so there's your P. $4,250 in an account that earns 5% interest. 5% is the same as 0.05. So you got to make sure you move your decimal point twice. So we start over. You deposit $4,250 in an account that earns 5% annual interest compounded continuously. What will the balance be after 10 years? So there's your time. It's another 10 again. So my amount is equal to my principal times E to the R times T. $7,007.06. That's what Macy. Is that what everybody got?
Yeah. Yeah, the 07.
It'd be 7 cents. Some 7 and some zeros. Alright. So the E, as far as just plain old work with the E, if you go back and look at your beginning notes there, we just treated it pretty much like a variable. You know, if it was a multiplication, we added the powers. If it was a division, we subtracted them and just kept an E on there. Here, we actually computed it, but we let the calculator do all the work. We didn't have to type 2.7, blah, 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 blah. We pulled the E up on the calculator. And then we learned how to tell if an E would be a growth or a decay. So we got all that covered. Now, what we're going to go to tomorrow, all of this stuff has been exponential form. So we've had a variable that's an exponent. I told you yesterday we did linear functions, quadratic functions, exponential functions, and now we're going to hit logarithmic functions tomorrow. Log functions, logarithmic functions, and exponential functions are cousins. They go together. The whole point of log functions is it teaches you how to solve for a variable that's an exponent. So that's why it links to exponential functions. So we're going to look at that tomorrow. We're going to do it a little bit differently tomorrow. We're going to watch a video and take notes. I've got a note guide sheet for you. We're going to watch a video and take notes off of that. And then what we still don't understand after that, I'll go over with you. But it's it's new, so it always, Algebra 2 is always slow with it in the beginning, but it's not very difficult. We just got to put a little effort in and stick with it. All right? Short and sweet today. Is that all right, Cameron? All right, Cameron approves, so. I'm Cameron Chenault, and I approve this message.